Now, a completely new type of 4WD vehicle has been added to Toyota's 4WD group. An on-road full-time 4WD. A full-time 4WD vehicle offers an advantage over part-time 4WD vehicles, as they can readily adapt to any condition. All are driven consistently, whether in on-road or off-road conditions. You are already familiar with this picture. It shows how a part-time 4WD mechanism is constructed. The engine is mounted along the car's length, and the power from the engine is distributed equally between the front and the rear in the 4WD range. In the normal mode, or 2WD mode, the power is transmitted entirely to the front wheels and none to the rear wheels. To construct a full-time 4WD from a part-time 4WD, Toyota added a differential between the front and rear differentials like this. The third differential is called the center differential. Let's examine the center differential using a model. It is built the same way as a conventional differential, and its operation is already familiar to you. The center differential distributes engine power to the front and rear wheels. On a full-time 4WD vehicle, the engine's power is first transmitted to the center differential, then to the front and rear differentials, and finally to the right and left wheels. But, as you already know, power is no longer transmitted from the engine to a wheel when the other wheel begins to slip. When one of the wheels slips, all other wheels stop running, as you see here. This problem, among others, is solved by adding a locking mechanism in the center differential. When the center differential becomes locked, the center differential case and the rear differential are locked like this. When the left front wheel slips, for example, the engine power is still transmitted to the rear wheels when the center differential is locked. The vehicle can get out of the slip situation as a result. On an actual vehicle, the center differential is locked with the differential lock switch. The center differential is controlled by a mechanical locking system. The center differential's operation can also be controlled by an additional viscous coupling device. In this video presentation, we will focus primarily on the mechanically controlled center differential. We will study the construction and operation of the mechanically controlled center differential. What the driver should know about its uses. What service technicians should know about it. And we will also study about the viscous controlled center differential. Earlier, we looked at the basic construction of a full-time 4WD vehicle. We will now examine the construction of a Toyota full-time 4WD system. The center differential in the Toyota full-time 4WD system has a unique design. The front differential is incorporated in the center differential to form a compact unit, which is located here. It also contains a differential locking mechanism. The transfer is located here. Let's study the transaxle first. This is the center differential. We will turn it horizontally for easier understanding. The driving power is transmitted directly from the transmission to the center differential case. The left side gear drives the front wheels, and the right side gear drives the rear wheels at different speeds. Remember that this mechanism is located along the front drive shaft. The next unit is the front differential. You already know how the front differential operates. It operates the same way as in front-wheel drive vehicles. The front differential is also located along the front drive shaft. Now, let's combine these two differentials. Here is an illustration showing a sectional view. Now you know you must connect the left side gear of the center differential to the front differential case, like this. The engine power is transmitted like this. But the shaft for driving the rear wheels is also on the front drive shaft. So, we add this gear here. The right side gear of the center differential, which drives the rear wheels, is connected to the transfer drive gear on the shaft. And the drive gear transmits power via the transfer-driven gear to the propeller shaft, which in turn drives the differential for the rear wheels. This part is for locking the center differential. The center and front differentials are combined in a compact unit. This model is basically identical in construction to Toyota's full-time 4WD system. Let's see how this model functions. The vehicle is running straight ahead. In this situation, the front and rear wheels are rotating at the same speed. Power is transmitted 50% to the front and 50% to the rear wheels. The front and rear wheels run at different speeds when the vehicle comes to a curve or turn. The speed difference is absorbed by the center differential. This prevents braking when the vehicle makes a tight turn. Now, what will happen when the front left wheel slips like this? When one of the wheels slips, power is no longer transmitted to the other three wheels until the center differential is locked. When it is locked, the engine power is transmitted to the rear wheels, like this. So the driver can get out of this situation. Let's look at an actual center differential gear unit. As you see here, both the center and front differentials are contained in the center differential case. The front differential is completely enclosed in the case. The left side gear of the center differential is integrated with the front differential case. This is the differential locking mechanism. We will now examine its construction using a sectional view. The parts are assembled in a very compact design. Engine power is transmitted to the ring gear of the center differential and causes the center differential case to rotate. This rotates the pinion gear since it is an integral part of the case. And power is transmitted to the rear wheels via the right side gear of the center differential. The left side gear of the center differential is an integral part of the front differential. Therefore, it causes the pinion gear of the front differential to rotate also. And engine power is transmitted to the front wheels via two front side gears. When the differential is locked, power to the rear wheels is transmitted from the center differential case directly to the transfer drive gear. Here are a few important things that the driver must remember about the transfer and transaxle with a mechanically controlled center differential. There are other things that are also important, and you should see the owner's manual in addition to this video presentation. First, the center differential lock is for emergency use only. The center differential may never be locked under normal conditions. Second, every time the driver operates the center differential lock switch, he must check that the center differential lock indicator lamp goes on when the switch is turned on and off when the switch is turned off. Third, these 4 pictures show how the vehicle may be towed away. Towing with a rope, as seen in this picture, is only to be used in case of emergency. Otherwise, towing by the other 3 methods is recommended. The vehicle must never be towed in any other way, since it will apply an extra load to the center differential. There are a few important things that technicians must remember about vehicles with a transaxle with a mechanically controlled center differential. As you know, the difference in speed between the front and rear wheels is absorbed by the center differential on this type of transaxle. If you turn the front wheels at a high speed for a long time when the rear wheels are locked or chocked, or vice versa, it will damage the center differential. Therefore, please refer to the New Car Features and Service Training Information publications for details before starting these tests and checks, as they may require some special preparation. 2 special service tools are used with this type of transaxle. Plastigauge is used to select the thrust washer for the center differential side gear of the mechanically controlled center differential. This is a center differential gear unit. The major difference from the mechanically controlled transaxle is this viscous coupling. Let's take a closer look at the viscous coupling. This is a cutaway model of the viscous coupling. It contains 2 kinds of plates assembled alternately with a small gap between them. When the inner shaft is turned, it moves the inner plates. As you see here, inner plates are built in such a way that they rotate as a unit with the inner shaft, and the outer plates are built in such a way that they rotate as a unit with the housing. The viscous coupling case is filled with high viscosity silicone oil. We will next examine how the viscous coupling controls the movement of the center differential. A beaker is placed on a rotating table. And we pour highly viscous liquid into it. This liquid into it. When we stir the liquid very slowly with a mixing rod, the beaker remains still. If you move the rod very fast, like this, the beaker starts to turn along with the liquid inside. This means a highly viscous liquid transmits power when there is a large difference in speed. It is this principle that is used in a viscous coupling to control the movement of the center differential. We will now study how the viscous coupling is assembled in the transaxle. Please recall the mechanically controlled transaxle. We will build a viscous controlled transaxle from a mechanically controlled transaxle. Let's remove the differential lock mechanism, as we do not need it now. The viscous coupling housing and outer plates are integrated with the drive gear of the transaxle. The shaft extends from the left side gear of the center differential. It is an integral part of the inner shaft, and the inner plates are fitted to the inner shaft. As you will notice, the viscous coupling connects the left side gear and right side gear of the center differential. This is the center differential gear unit. The inner shaft of the viscous coupling is connected to the left side gear of the center differential. Its outer plates are connected to the right side gear of the center differential. Now, let's examine how the viscous coupling works. When the car is running straight ahead, the front and rear wheels turn at the same speed. The inner plates turn at the same speed as the front wheels, and the outer plates turn at the same speed as the rear wheels. Since both plates turn at the same speed, the viscous coupling does not transmit engine power in this situation. This shows what will happen on a vehicle carrying a mechanically controlled transaxle when one of its front wheels slips. However, when a wheel slips on a vehicle that has a viscous controlled transaxle, the inner plates start to turn faster as the front wheel turns faster, and there is a difference between the inner and outer plate speeds. As you saw in the experiment with the viscous liquid and a beaker, the outer plates turn at the same speed as the inner plates due to the viscosity of the silicone oil. In this way, the viscous coupling works to eliminate differences between the front and rear wheel speeds, and thus controls the operation of the center differential. Thus, the driver can exert control when one of the wheels slips without the help of a mechanical lock. There are a few important things that technicians must remember about vehicles with a transaxle with a viscous-controlled center differential. It is very dangerous to carry out certain tests or checks on these vehicles in the same way as conventional vehicles. It is not only dangerous, but will also seriously damage the transaxle. A difference in speed between the front and rear wheels is controlled not only by the center differential, but also by the viscous coupling on this type of transaxle. If you turn the front wheels when the rear wheels are locked or chocked, or vice versa, the vehicle may jerk suddenly, which could lead to serious consequences. Therefore, please refer to the new car features and service training information publications for details before starting these tests and checks, as they may require some special preparation. Here are the specifications for the kind of oil developed for these transaxles. The compact center differential, based on Toyota's creative technical development, is the heart of the new type of full-time 4WD vehicles. In this video presentation, we have explained about the construction and operation of the transaxle and transfer, focusing on the full-time 4WD system with mechanically controlled and viscous controlled center differentials. We have also explained some points you must remember about operating and servicing them. We hope that you have thoroughly understood the contents.